Section 6.7 talks about page 484, hyperbolic functions. I'm just going to cover a brief piece that we need for differential equations and 5c. So, it looks like trig, sine, hyperbolic sine of x is e to the x minus e to the minus x divided by 2, and hyperbolic cosine is e to the x plus e to the minus x divided by 2. That's all you need to remember. I do want to point out that this is something I'm not going to give you homework on. Derivative of hyperbolic sine of x is the cosine of x, and derivative of hyperbolic cosine of x turns out to be positive, not negative. So hyperbolics, you really don't pick up the negative. But we're not going to do the calculus. We're going to do the most crucial for what we need, which is evaluation and really limits. So on page 489, I'm looking at problem number 4. It says, evaluate the hyperbolic sinh, that's how you pronounce it, sinh of x, cosh of x. Sinh and cosh. So this would be, based on this definition, e to the 4 minus e to the minus 4 divided by 2. That would be e to the 4 minus 1 over e to the 4 divided by 2. That is e to the 8 minus 1 over 2 e to the 4. There it is. If I take the hyperbolic sine of natural log of 4, well, keep in mind, these are the only things that vary. And there it is. That is e to the natural log of 4 minus e to the negative natural log of 4 divided by 2. That is a 4 minus, make that a power. Wouldn't that be e to the natural log of 4 to the negative 1 over 2? That is 4 minus 1/4 over 2. Again, a complex fraction. 16 minus 1 over 8. That is 15 over 8. And that's how you evaluate those. And if I look for the hyperbolic tangent, well, look, something that you should keep in mind, the trig identities hold for the majority of those. We say this is the hyperbolic sine of 0 over the hyperbolic cosine of 0. Hyperbolic sine of 0 is e to the 0 minus e to the 0 over 2. And this is e to the 0 plus e to the 0 over 2. The 2's cancel out. That is 1 minus 1, 0 over 2, which is a 0. I'm not really a big fan of evaluating those. I am a big fan of limits, and there's only one problem on limits. I'm going to do a part. Number 23 has a lot of parts. It says use the definition of hyperbolics to figure out what these limits are. I'm going to say this is the limit as x approaches 0 from the right. So I'm going to say this is the cosine over sine. Again, all of these identities hold. You could look in the book. They have about 32 identities you could look at. So hyperbolic cosine is e to the x minus e to the plus e to the minus x divided by 2. And hyperbolic sine is e to the x minus e to the minus x divided by 2. The 2's cancel out. This is the limit as x approaches 0 from the right of e to the x plus 1 over e to the x over e to the x minus 1 over e to the x. Couple of ways I could do that. This is the limit as x approaches 0 from the right of e to the x plus e to the 2x plus 1 over e to the 2x minus 1. If I plug in the 0, I'll get the limit as x approaches 0 from the right. If I throw a 0 in, I'll get e to the 0, 1 plus 1, that's a 2. 1 minus 1 is 0. So I know from 5a, this is either positive infinity or negative infinity. How am I going to figure that out? Well, it all depends on the sign of this. If I take e to the 2x is exponential growth minus 1, shifted 1 unit down, the graph looks like this. And if I'm taking the limit as x approaches 0 from the right, that indicates that this is always bigger than 0. If this is positive, then that limit will simply be infinity. There are a couple more ways you could get that answer, but until we get to 6, 8 and finish it, there it is. And there's your homework on this section, a very short section.